Thank you for the introduction. As you heard, I'm Martin Fischer. I'm a professor of civil and environmental engineering at Stanford University, and I direct the Center for Integrated Facility Engineering. I teach classes and do research in project management. So I thought this t-shirt was somewhat appropriate for the topic of the conference. So I'm speaking to you today from my garage in Silicon Valley, but I actually travel quite frequently to Copenhagen. I was there a couple of weeks ago on the invitation of Kasper Goldar Jensen for a circular economy event, and I will be back in a few weeks when we reflect on our SciFi annual conference, the SciFi Summer Program. So I'm happy to talk to you about the value of open data today, also because I can do so with open windows. Finally, we have good air quality. This has become the first thing you look at when you wake up in the morning is what do the air quality sensors tell us. A website I was unaware of as of a few weeks ago. But of course, the fires have been quite devastating. They've burned an area a third the size of Denmark so far. Of course, devastating for the people affected directly, and also not so pleasant for us with all the smoke and poor air quality. But to the topic. Why was I interested in getting involved with OpenBIM? Mostly because I was lazy, still try to be. When I was a young engineer on this bridge project in the eastern part of the US, I felt I had to spend way too much time working for the information instead of the information working for me. And I didn't like it. I thought this should be much better. Basically, I wanted to be lazy about data management. And so so that got me into BIM, and then when International Alliance for Interoperability was founded, I immediately said, yes, this makes sense, we have to work on this. So one of the first reports we wrote starts like this. For the past decade, the holy grail for the field of information technology, the architecture, engineering, construction, and facilities management industry has been information integration throughout the suite of computer tools used to carry out engineering projects. Vendor-specific approaches have been developed, but these are limited in their coverage of the range of potential applications and users. An open industry-wide solution is required, but this can only exist with standardized data models to support the exchange of information among disparate systems. So as I was preparing for this talk, researching some of the things we had done, I came upon this opening paragraph, and I had to kind of cry and laugh at the same time because we wrote this in 1999. But it's actually still, I think, quite applicable today. We had a AEC hackathon, we didn't call it that at the time. Might have been one of the first ones. We spent 3 days at SciFi at Stanford figuring out how do we make IFC for project management work. And that was sort of kind of insights we gained from it. We really thought at the time that we had uncovered the recipes to over-connect the different silos that exist in our industry because of disciplines and phases that we have in our projects, of course. Because we saw so many advantages from using open data to make the workflow go better and to create a better result, that we thought in no time the industry will take this up. Because it was very obvious to us that without data, there is no process, no result. In other ways, right? You cannot do anything without data. You cannot do anything well without good data. So we saw very clearly when we have open data based on open standards, the quality was higher, the process got better, and the result got better. I was also happy to discover that other industries pay attention to process. Like here, on a visit to Carlsberg Brewery, one of my many actual trips to Copenhagen. The trips I mentioned before, of course, are all via Zoom, sadly. Of course, I always enjoy my visits there very much, professionally and privately. So, obviously, process is very important to get the result that you're interested in. So we realized that this technical argument was not quite enough, so that we had to do some research on the business aspects. I was actually quite upset about this report that came out many years ago that put the value of interoperability at 15 billion. I think it's way, way too little. But anyway, that aside, we were able to follow a group of engineers, well, actually, the engineers in a major engineering office in San Francisco for 2 weeks to see how they spent the time. And we found indeed they spend 36% of the time doing engineering. Well, okay, they're engineers, you would expect they spend some time being engineers. And we saw what are they spending the rest of the time on. We found that they spend 6% of the time planning engineering. Yeah, that makes sense too. What do they do the rest of the time, the 58%? We realized, or we found out from our research, that they are spending it managing data. Which we thought was kind of crazy, right? That 6 out of 10 engineers focus on the data, whereas 4 actually focus on engineering, what the company sells. Because, yeah, lots of issues to deal with as you bring data from one tool to the next, as I'm sure you know from your own work. We also did a study of just workflows. What if we digitized workflows and connected all the steps in the workflow with open data? Here we looked at quite a few processes. This particular data point is from an analysis of the payment application process, something that every company needs to do and is quite dependent on. And we found that effort for payment applications could be reduced by 84% if we were able to connect the different steps with open data. So we thought certainly these business arguments will sway everybody to jump onto implementing open data, but I think we were maybe a little bit early with these findings because the digital tools really were still emerging as we were doing these studies. Now, of course, we see lots of use of the cloud for sharing information, and this was actually also done a few years ago, but I think it's really still quite typical in projects, at least around here, where, well, what we're able to see here, sorry, I should explain the table. What we're able to see is who writes data and who reads the data. So on top you see the disciplines that write data, and then you see who picks up the data on the left. And the darker the square that connects those two rows and columns, the more data is shared between those disciplines. And this was actually very interesting with the project manager when we showed him this data set, because he said, oh, now I see why we had all this trouble on the project, because you notice here that the mechanical equipment designer didn't read anything or didn't download anything that the MEP designer and producer, the HVAC subcontractor, construction engineer, and they were the electrical contractor. Little strange, right? Because you would think there's interfaces there that they need to pay attention to, and of course they had lots of interface issues on the project. So anyway, but that aside, we then also wonder how, from what tool to what tool are these data flowing? And so we were able to look at basically the same data set and said, okay, what are the most frequent exchanges of data? And one of the most frequent one is from AutoCAD to Revit, Google SketchUp to Revit. You know, but we also see from Excel to Ecotech, from Revit to Ecotech. Images were brought into Revit. I mean, yeah, all kinds of things. ETABS, structural analysis to work. So this shows you the most frequent information flows between different applications. On this project, they were not using open data. So as a result, right, they had to custom make these interfaces. And then, of course, this was a long project. When software updates happened, it became a challenge because they either have to decide to do the software update and probably update also the interfaces, or we keep working with the older software and the interfaces work. So not really the world we want to be in. Because now we still have the silos, and now we have more data in silos, but maybe now we have also some motivation and something that we can actually connect with open data. The keyword here that we learn in all of these studies is latency. Because it's really, when you have short latency, you speed up the project, you have much faster cycles, you can look at more options, you can make better decisions because you probably have a better information basis than when you have long latency, like illustrated in the picture in the back, where a drawing produced from a bin, quantities were taken up like this for that cost estimating. Of course, delaying the time when the cost estimate was available to allow the owner to make a decision on this option or that option. So latency is really the key thing to pay attention to if you want to have a better project. So what makes latency break, or what slows it down? What we have found again and again, and I'm showing here the experience from the very first study we did like this, where we really focused on the information flow between the client, the architect, structural engineer, mechanical engineer, and contractor, which was the first application of an IFC for these disciplines to share project data on an actual project. That was in 2000 on the Helsinki University of Technology electoral project. And eventually, the seamless flow of data broke at the professional interfaces between the disciplines, because each discipline had to slightly massage the data from the other discipline. And that was not a big deal initially, but as they had to redo it, as the project went through iteration after iteration of design exploration, people got fed up with it and basically stopped using the integrated information, or limited use of the integrated information, which was sad. And it's still what we see on most projects today. So how can we move forward? I think we have to keep doing more of what we're already doing today. We have improved the standards, those schemas dramatically. We have more schemas, and we have better schemas than quite a while back. And I'm really delighted by the many efforts that I see and focus on airports and infrastructure, roads, and many, many areas around the world. So that is really, really good news. Of course, we have to keep standardizing, we have to keep improving the processes, improving data management. But I think we also need to pay more attention to the interfaces, right? We don't only need the schemas of representing the things we have, we also need to think about the interfaces, as I tried to show. If we can make the interfaces work, we can really reduce latency, improve projects, create more demand. We need to focus maybe more on the application. There's a bit of a chicken and egg situation, right? Do we apply first and then standardize, or do we standardize so we can apply better? I think it's difficult, in my experience, to imagine all of the applications before you standardize. So I would err on the side of more application, and then soon after that, though, standardize what makes sense to standardize. We should not just improve today's processes with a bit better information. We should really look at potential for automation, because that can dramatically change a process. We've seen in many examples where a process that takes 4 hours that maybe could be improved a little bit by connecting the steps better. But when you automate it, we are done in 3 seconds, enabling a totally different way of working. Of course, also leveraging open data. Of course, we have to manage the data between silos and within silos, but we should really pay attention to data flow and then manage the data. So when the project has done that, the data management has changed dramatically. Maybe one of the most important things we need to get out of is sort of try to get rid of experts, and so to make it everyone's job. Because when you go into an office and you say, so do you guys use buildingSMART? Oh yes, we do that. There is Mette over there, or Søren over there. We have a guy, basically, or girl, or woman. That's not what we can do here in 2020. It has to become everybody's job, because everybody needs the data, everybody needs to produce results, and so it has to be everyone's job. This is particularly critical in light of the many digital solutions that have been emerging and that keep emerging. And here I'm just showing a few, right, from BIM-based design, construction, scanning, BIM to field, also BIM to FM, robotics, design automation, layout, fabrication, virtual reality. There's many more. These have all emerged on a big scale now, and each of them have their interfaces in terms of data and data flows. And we will be far, far better off if we can put all of this on the basis of open data. So I look forward to learning from you about the results from the conference. Thank you for taking the time to pay attention to this and for your continued effort in advancing this important topic of open data. I hope I've been able to show you the value of open data and reflect on how we can further enhance the really good work that has been done so far.
Thank you. In California, more so than in many other places in the world, your plate seems to be quite full.
Thank you for the question about the impact of virus and the virus here in the Bay Area. Yes, it has indeed been a bit challenging, as I already alluded to. I would say, though, professionally, what I hear is things are going reasonably okay for the time being. Some markets, like factories for vaccines, data centers, of course, are incredibly booming, healthcare. Others are still going, but I am a little worried looking out about the backlog, the pipeline. I think we'll see some shifts in industry sectors that are busy and not so busy. I imagine that's similar in Denmark. So professionally, people tell me they have been going quite okay also, I think because they finally have no more arguments in the office about the value of digitalization. That's now very obvious to everybody. And the companies that have digitized beforehand really moved into working in a distributed fashion very, very easily. But I imagine that's quite similar in Denmark also. I would say on the private side, it has been much tougher because of Corona, you cannot go into buildings, at least public buildings. So the life is really outdoors, and now because of smoke, you can't go outdoors. So that has been a tough few weeks. So if you're dealing with people in the Bay Area, please have a little patience with them. So, but I hope you're doing well in Denmark, and wish you a successful conference.